Myself, Dr. Shalini Dwivedi, Assistant Professor, Chemistry Department, VSSD College. Today, I am going to tell about the topic Fundamentals Aspects of Polymers. Polymers are very large molecules made when hundreds of the monomers join together to form long chains. The word polymer comes from the Greek words poly means many and mer means parts. Polymerization is a chemical reaction in which two or more than two molecules of same compound or different compound combine together with or without evolution of anything like water, HCl or NH3 to form a large compound. This large compound is known as a polymer. This means whole process is known as a polymerization. And in this, polymer formed. Polymer is used as a synonym for plastics. All plastics are polymers, but not all polymers are. Means all plastics are the polymers. Example, we have taken N molecule of ethylene, formation of polythene. Next, degree of polymerization. A chemical unit which repeats itself throughout the structure of a polymer is called as repeating unit or structural unit of the polymer. The degree of polymerization dP is defined as the number of monomer units in the polymer. The average molecular weight of the polymer is equal to the product of one mer unit and the average degree of polymerization. Therefore, we can say that higher dP values is shown the product desired for better mechanical properties. Next, characteristics of the polymers. Polymers, they have a chain of molecules in which large number of atoms combine consecutively. Means they have basically two kinds of bonds are present. First one is chemical bond and other one is intermolecular bond, and these bonds are mainly made up with covalent bonds. Second one is they have average molecular weight. Average molecular weight due to polymer propagation chain have a different kinetic length and termination may takes place by combination and disproportion, and in this case we obtain the polymer having average molecular weight is of four types. Number one is number average molecular weight is abbreviated as Mn. Second one is weight average molecular weight, abbreviated is Mw. Third one is viscosity average molecular weight, abbreviated as Mv. And jet average molecular weight, this is the final, and it is abbreviated as Mz. And in this way, the relation between all these average molecular weight are Mw is greater than Mn, Mn is greater than Mv, and Mv is greater than Mz. Next, characteristics of the polymers are polymers can be very resistant to the chemicals. Next, polymer have no sharp melting point but a softening temperature range. In this point can better understood in this way, like compound have a sharp melting point, but in case of polymer, melting point is not a peculiar. Here consider a softening temperature range. Next one, each polymer has a transition temperature. In case of crystalline polymer, when the polymer is in crystalline phase, it is known as crystalline melting temperature. But in the case of the amorphous polymer, it is known as glass transition temperature, is abbreviated as a TG. The temperature above which it behaves as a glass, below as a polymer. Next point, polymer can both thermal and electrical insulators. Next, polymer dissolves slowly in the solvent. There is no saturation point. Therefore, the viscosity of the solution is higher than that of a solvent. Polymers are the materials with a seemingly limitless range of characteristics and colors. Another characteristics of the polymers are low density, low coefficient of friction, good corrosion resistance, good moldability, poor tensile strength, low mechanical properties, poor temperature resistance, and finally can be produced transparent or different type of colors. On the basis of, we can discuss the type of polymers. First one is natural polymers. Natural polymers, as the name design means, polymers are occurred from the source of the natural origin. Second one is homopolymer. Copolymer, thermoplastics, thermosets, long chain polymers. Natural polymers, by the name designed, natural polymer is a polymer that results from only raw material that are found in the nature. Some of these natural polymers include DNA, deoxyribonucleic acid, and RNA is ribonucleic acid. Examples of the natural occurring polymer are cotton, DNA, wool, wood. And next point is homopolymer. This is another type of polymer. It is made up of the single type of monomer. When single monomer can join with each other, then the formation of homopolymers takes place. Like example, polystyrene, polymethyl methacrylate, polyacrylonitrile, polyvinyl acetate. These are the examples of the homopolymer. Second one, characteristics of the homopolymer are consist of the chains with the identical bonding linkage to each monomer unit. Third one, this usually implies that the polymer is made from all identical monomers. Second one is a copolymer. When two or more different monomers together to polymerize, their result is called as copolymer. Copolymer, as the name design, co means together. When two different monomer join together, when two different monomers join together by means of the process with which to polymerize, then the formation of copolymer takes place. This whole process is called as copolymerization. Types of copolymer. First one is statistical polymer, alternating copolymer, block copolymer, and Kraft copolymer. In this first one case is statistical copolymer. In this, repeating unit are arranged in a regular fashion. Alternating copolymer, a copolymer in which the two monomer unites are placed in an alternate fashion is called as the alternate copolymers. Third one is block copolymer. It is a linear copolymer in which one monomer unit form a block. Last one is a graft copolymer. It is a branched copolymer in which one monomer unit forms one block and the other monomer units forms the other block. Thermoplastic polymer. On the basis of the engineering properties, we can say the polymers are of two types. First one is thermoplastic and next one is thermosettings. Thermosettings we will explain in the next slide. Thermoplastic, a type of the polymer plastics that can be softened by heat, hardened by cooling and then softened by heat over and over again. Example of this thermoplastic polymer is polyethylene, nylon, polyvinyl chloride, polyacrylonitrile. Thermosets. This thermosets polymers cannot be remolded due to cross-linking, and these having the properties of become permanently hard and rigid when heated. Thermosets are hard and rigid at room temperature and don't soften on the heating. Examples are epoxy resins, phenolic resins and unsaturated polyesters resin, and polymers like the bakelite and nylons are the wonderful examples of the thermosetting polymers. Long chain polymers. These are long chain polymers is a important type of the polymers. This is a very long strand of the repeating molecules linked together by primary bonds. Polymer chains or orient themselves in lines and they enter a mold, but they may be annealed so they can